right. Morning, everyone. This is a new session. Paul is here. We'll wait for a couple of people to join in. Looks like Brano is busy today. I think also Nick is not going to make it, but I think Sam is about to hop in. How are you doing, my friend? With your redding.
Yeah, it's the light because I've got red curtains. When the light shines through from outside, it just makes the whole room glow. Well, but weird, it doesn't look red in here. It's just the camera picks up that the light
Mm,
is red, so
mm,
it's
mm-hmm.
kind of strange.
Gotcha.
I've had a bit of a confusing week this week.
What
I
happened?
downloaded this thing, Sonar Cube. Have you ever heard of it?
Yeah, the sonar cube to detect the coverage.
Yeah, so it's kind of interesting.
It
Basically,
sucks.
the bulk of the feedback,
Go
yeah,
ahead.
the bulk of the feedback that it gives you is kind of what Roslyn gives you anyway through
Mm-hmm.
from the compiler. But the bit that's particularly interests me about it is like all the information that Visual Studio hasn't told me.
Have
So
you
I've spent
have you tried to run the analysis in Visual Studio?
I have, yeah, and it's kind of interesting because like when I run a full analysis on my solution, it says, "Hey, I found like these 10 things or whatever," and I go, "Great," and I clean up those 10 things, and I'm all good. I run SonarCube on it, and it goes, "Nope, your entire code base needs throwing out. It's complete garbage. Start again." And I'm like, "Whoa!" And it's like silly things. It's like, so the one I'm currently looking at is like the way that I implement iDisposable in inheritance hierarchies. And there's some really like peculiar rules that SonarCube has on it. Like it says like in your dispose method, without a Boolean parameter, you should have a call to one with the Boolean parameter and then GC suppress finalize, nothing else. So of course I've got like a dispose, is disposed private variable that I'm tracking. So when I call it without the parameter, I set that to say, hey, I've already disposed of it as part of that method. That extra line being there is a big problem apparently, because there's 3 lines of code in my dispose method instead of 2, and I'm like, how can I do that any different?
No, yeah, they know that's like seems like an opinionated kind of. This is why I don't install style cups. People keep telling me, "Oh, add these measures to block code." I don't believe in style cup. I don't believe in, measurements that tells me how to write my code. It needs to come as a conviction. You know what I mean? And
Yeah.
someone asked me that question the other day. Someone said, "Hey, Hassan, I discovered a way that if people are not naming their pull requests the proper name, like, we have like infrastructure, orchestration, services, foundations, whatever. You said it will just reject the pull request or just throw an error. I said I don't want that because that means that takes away the conviction from the engineer and puts it into the machine. And now you have, an overlords that are telling you what to write, what not to write, and it takes away your ability to ask questions and be able to understand why you're doing what you're doing. So this is I was having this discussion yesterday with a bunch of people, Ricky, Elbic, and a bunch of folks about humanizing regular expressions. And this came up, I said to them, well, it's very easy that we allow the machine to kind of control us, and it takes away from our ability to do things, right? Like people in the past used to be stronger. Paul, if you ask your dad or your grandfather, if your grandfather's still around, he'll tell you people used to be much tougher than they are today, right? The direction of how we build technology is actually devolving us.
Yeah.
There you go. So, see what Sam just did? You see what he just did? He just caught a Did you just catch a
Uh,
There's a
fly?
bug.
Yeah, a bug.
Yeah.
Okay, so you see what he just did? Nobody knows that this tells me that this guy grew up in the 80s and the 90s, because now people will be like, "Oh my God, a bug. Let's run away. Let's see what happened." Sam would be like this. Hold on. Sam would go like this. That's good.
protein.
How you doing,
Same.
Sam? Sam, there is
Um,
this guy that we need to help. I sent you an invitation, just keep letting you know right after this session.
Today, right?
Yeah, he's a CTO in a company in
Sorry.
Portland.
I just finished my deep teeth clean
Yeah, so you can't
this
speak.
morning.
Yes.
I, it's, there's no feeling
You can't feel
this
anything.
part.
Do you know I've never
Yes,
been
this
to a
part.
dentist in my whole life? I don't go to
Oh,
dentists. I never had a problem with my teeth.
really?
You are
Yeah.
lucky.
Yeah.
That is
Oh,
super rare.
I'm the only person in my family that never had to do anything with my teeth.
Mhm.
I also have
it's
very
not
strong teeth. Hmm.
it's not
Like
a good news for the dentist.
it's not good news for the dentist. You know, when I went to the dentist, the lady was just cleaning my teeth. Like
Hmm?
she said, "Come to clean your teeth," and I said to her, "Do I need that?" She said to me, "Well, you should." I said to her, "Have a good day," and that's it. That's the only time, I actually went to a dentist. I didn't have to, I didn't have to do anything. Yeah, dentists and me were not good friends. Also,
Hmm.
barbershops. Hey, Paul, who cuts your hair?
What do
His
you mean,
wife,
who cuts
probably.
my hair? Why?
Do you go to a
Himself.
barber shop?
Yeah. So I've got this really weird thing, right? They call it a double crown, and it's
Okay.
basically my head is a funny shape,
No,
but
it's okay.
also
It's nice. I like it. Uh-huh.
but also the way that my hair grows, right? I can style this any which way I want, right? And it will
Yep.
always end up like this, no matter what I do, right? I could spend like 6 hours putting all the hairspray and everything on it, and you can guarantee within 10 minutes it'll just go and it'll be like this. So I just give up. I just gave up. Look, I came out of the shower like half an hour ago, right? My hair looked like flipping something out of, Wurzel Gummidge or whatever.
Yep.
And like 10 minutes later, it had dried and it's like this. I never brush my hair, nothing. It does it. So
Interesting.
I've just learned to accept it now.
Okay. All right. What
Yeah.
about you, Sam? Who cuts your hair? You cut your own hair. You just pick up the machine and just go.
Yeah. Sam just
Just
goes,
go. You
job
know,
Me
done.
myself.
I'm so jealous of this guy's hairline. He's fine. He's set. I don't have that stuff. I have to
What,
overcompensate.
hairlines?
Yeah, with the hairline,
You're
I have
just
to
all hair.
overcompensate. Yeah, I have to just bring a little bit on the front like this just to make sure. All right. Listen, guys. So last time we were just discussing the Lexer algorithm, right? So, Sam, we talked a little bit about, so here's we need to move forward with this, right? We already have the dictionary that tells us what's what, right? The one thing
Hmm.
I don't want to do, Sam, is that I don't want to go and, I want to write simple code that is easy to understand. What that basically means, did Joe cut his hair? No,
Hmm.
he's
Oh,
just we were just
Shaved.
talk Joe, we
Ju-
were just talking
Just
about
getting
hair and he shaved.
no, the hair's still long.
Okay.
It just is a little disheveled.
Oh my God, he looks very different without
yeah, very different.
beard. Okay. So I'm the only one with a beard at this point now. Okay, fine. You suckers. You all look like little kids.
Younger.
When you get to my age, you want to look younger.
All right. So the one thing I don't want to do, I want to find out a way where we can Paul has Paul had a good idea. Paul said, we don't have to read the string left to right the way, you would read it because our brains actually are looking for patterns. You are reading it. I want our code to resemble the way we look at code. Like you guys are looking at this code right now. What are you engaging in your brain when you are trying to understand this code? I'll tell you what you're engaging. You're engaging memory. You're trying to see what are the things that make sense to you. And then you're trying to pluck out patterns out of this. So, do we here's what we can do. We can use regular expressions to basically find certain patterns. And if these patterns match, then we can pluck these patterns out. Like for instance, you can go and say, I have an expression. The big problem here, like something like this in here, this block here, I'm gonna put it in red. This block here, you could have a regular expression that goes and says, find me something that starts with a single quote and ends with a single quote, and pluck that out as a token. Do you see any
So
problem with that? Go ahead.
So when I first started talking about lexes and things, the idea that I mentioned back at that point in time was that we had like a dictionary of, if you like, token rules or like matching expressions.
Yes.
So that would allow us to have, say, you could take some piece of the source input and you could run it through the dictionary, and the first item that came out and said this is a match, based on executing the functional rule that was the value in that dictionary, that would be your kind of token type. I kind of deliberately presented that as a potential option because then it left it open that if in those rules we wanted to use regular expressions for certain cases, we could, but we weren't entirely bound to it. I think if you try and treat the whole thing as a giant regular expression type thing to be parsed, you're going to end up giving yourself so many headaches because there's so much complexity to strings, and in particular query strings like the sort that we're trying to parse, that you'll just never be done building the regular expressions for it. And I would say that, you know, regular expressions have a purpose. There's a use for them, but as much as possible, you want to avoid using them because whenever you need a regular expression, it's your last resort to solve a problem, and it's always hell to maintain. And what you don't want is people shying away from working with this because they fear regular expressions.
Well, they won't be. Ideally, they won't be dealing with regular expression. I'm trying to build this library that basically abstracts away regular expressions, makes it simple.
Yeah, wasn't that in your latest video
Yeah.
stream you were talking about? Yeah, I haven't managed to watch that.
I haven't even like.
You
Let me
annoyed
just.
me on that. I wanted in on that one, and you didn't mention it to
Then
me.
come in. Then come in. Then are you in
didn't
the?
tell me it was coming up.
Are you in the standard Discord channel community?
I'm in your one for OData. I didn't know there was a standard one.
Oh my God, dude, my biggest community is the standard community. You're just in one little branch, offshoot on the side that doesn't
All right.
even. I'm thinking about even merging the OData back into that community, you know. So
Good.
it'll be all just one standard community, and then there's a whole bunch of sleeper cells. Let me just explain to you what we're building on the side so you understand. This here, Paul, and you might have a simple idea of it. I'm sorry, Joe, you were going to say something first. Go ahead.
Oh yeah, I noticed that you guys started the regular expression channel over there earlier. So
Yep. Please hop in on that. I
yeah,
need your help
that
actually.
one's an interesting one. I'd like to toy around and
If you join me on that, and Sam, please also consider if you join me on that, we can roll out a NuGet package that will change regular expressions for the world. Everyone needs regular expressions. It's not going anytime soon. But if we make it simple, but it's really challenging. Like, please watch the session because what I said to people yesterday, I said, listen, I don't want some clown coming and telling me, oh, I'm going to make it fluent API by going and doing something like this. Let me just help you understand the challenge. You'll see tons of libraries that go and say this expression and then dot and then begins, right? And then they go and say, with range of, and they say from A to Z like this for at least, right? And then times once or something like that. And this guy will and then end, right? And this guy will translate to up carrot. What do the British people call it, by the way, Paul? Do you call it up carrot too, or what do you call this?
Yeah, it's just referred to as a carrot.
You just
I
say
believe.
carrot?
yeah, I've
Could be
only ever
wrong.
known it as carrot.
Just carrot?
Yeah.
Okay,
Yeah.
cool. So this would do something like this: A to Z, and then for at least one time, and that would be it. That would translate that to. Any clown could do that. There's no magic in that. Okay? What I was telling them yesterday is this is pretending that you're fluent, but you're still controlled by the way regular expressions work. So if someone is not familiar with how regular expressions work, you're fucked, right? You're screwed, right? What I want to do is that I want to find a language. If I were to go to anybody, someone, especially someone who's not computerized, someone who's not in the tech industry, and telling them, hey, if you want to tell someone, give me any letter for at least one time, what would that look like? And then this guy, just out of the blue, this is what I love about open source, just building in the open. This guy came out of the blue and he said, hey, why don't you do it this way? Check out this guy. I love the openness of building software. It's called humanized expressions. This guy came in here and he said, wait a second, why don't you say extract all words from lines starting with unless is followed by? There is some humanization in that. It's not exactly there, but I feel it. I see what he's trying to say. You see what I'm saying? Let me zoom in a little bit because this thing is really small. Let me remove this side. How do I hold on? Let me, yeah.
I mean, that's
So
just basically what we're doing now. You just go in
is
the
it
opposite
though?
direction. Yeah, you're basically translating this fluent. It's a thought pattern. That's why we do it this way. We type it out, and then basically at the end of it, you translate to whatever you want.
The problem with that is like
Expressions.
what constitutes a phone number, what constitutes an email address. Like if you've got an API that says, "Hey, get me all email addresses," okay, great. What how do you match that? Because it's an extremely vague expression or an extremely vague statement of intent.
He might have come short a little bit with saying words and phone numbers and all that. I agree. But if he stays at this high level and says, you know, I don't necessarily agree with the word extract all, but again, I said it's a good start. Like I'm looking for inspiration. I'm
It
looking for
depends on the regex you're trying to do. Extract all's part of it. There's a few other mechanisms you can do. So however that starts will be slightly different. And I would almost say that email or words are extension points. That could
that's
be a
right.
whole other set of regular expression that defines what that thing is.
I agree. And I'm just trying, I can't wait to think of creating that core library and then creating extensions so nobody ever have to go look what is a regular expression for an email address or a phone number again, ever. But that's an extension. That's like an offshoot. I'm talking about being able to express regular expression rules in a simple way. I like our Turing test is to bring someone who never done regular expressions in that. Well, first of all, I said to them, you have two missions, two tasks. The first task is to bring someone who never done anything with programming, has nothing to do with programming, and you show them your code, and somehow they figure out at least to a percent, 90%, 80%, what it's trying to say. And if they pass that one, then we need to bring in someone who is in the tech industry, maybe used irregular expressions a couple of times 50,000 years ago, and then give them that library and tell them we want to write a rule, to basically prevent, to allow only phone numbers that start with 3 digits, dash 3 digits, dash 4 digits. This is, Paul, this is how the phone numbers are here in the US. So if you were to express that, does this look like something intuitive to you to use? The problem
Yeah.
with a
So
lot of, go ahead, go ahead, go ahead, go ahead.
so when I said to you, what is the definition of a phone number? You expressed there that there is a format that's accepted for US phone numbers, and there's a slightly different one in the UK.
Mm-hmm.
But if you can explain that in human terms as a
Yes.
line of code
How?
fluently,
Like how? That's the
well,
problem. Like you
well, I
want to
mean,
go.
the
Mhm.
easy way is to say, well, how would you say it? And then build an API that reads exactly how you would say it. Right? I mean, like I've had.
Well, how you would say it, Paul? How would you say it?
How would I say what?
How would you say phone numbers? Phone numbers are supposed to have 3 digit, because the computer is influencing your language. Like we're infected. We're not good subjects for it. But you want to say 4 digits dash 3 digits
Yeah.
dash 4 digits. See, I am writing this and I know I'm computerized. I'm infected because I'm writing it as if I'm telling a computer
Okay.
about
So
this.
take the threes and put
Okay?
them in brackets after your digits.
In brackets.
Yes, like a method call. So do digits brackets 3.
Like this?
That's it. So do that for the whole line. And then what you do is you put dots between everything.
Okay, so digits, dot digits, dot digits like this.
Yeah, sort of, but you've missed out the dashes, right? So then we add, yeah, either dash or, you know,
But now it's too expressive.
then char or something, you know, then char, and then you just
Oh,
give it hyphen.
then Cha?
Yeah, then character or, you know, or just
Oh,
then.
char, char. Gotcha, 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 gotcha,
Yeah,
gotcha.
yeah.
Char. Okay.
Or yeah, or just then you could shorten it to if you're going to accept a string in there rather
But
than a
now you're
character
saying
literal.
now you're saying char. Boom. Computer language detected.
Yeah,
No.
so remove char from that. So it's just 3 digits, then dash, then 3 digits. There you go. That's literally how you would say it, codified fluently. So this is how people get to understanding like SQL so easily, because it reads almost like English. You're building a query. In fact, I've had people say to me that link makes more sense than SQL because it turns it on its head, doesn't it? Because you're saying from your thing, select this stuff, whereas SQL's more select this stuff from this thing. And there's different sort of thought processes and different mentalities on how you break these things down. This, I guess, is going to feed into like how we want to approach Lexas in general.
I know.
In our
That's
project.
it's amazing how things are all connected. This is why I'm talking about this right now. Because
Yeah.
but then again, Paul, this is also wrong. Why? Because if I were to say this, like digits, what does that even mean? What if you want to say only digits? Like in the US, you can't have a phone number that starts with 0. Like there's no such a thing. Like you can't go and say 01323 like this. Is there something like that, Joe? Have you seen anything like that? Like this guy is never a 0 at the beginning.
Yeah. Well, you could have like digits in range, and then you could specify, you know, start and end of your range. So you could say digits in range 1, 9.
Well,
Digits.
I mean that particular case would pass through a regex anyways, because you're just
Damn.
basically saying these characters are 0 through 9, and you're
Yes.
not saying like the first one can't be a 0. I mean, you can, but no one does that. They just said, "Hey, these are 0 through 9, and they're in this pattern. Here you go."
Like
I do think this particular one, because the regex you can validate if a string matches something, kind of lends itself kind of to like the shouldly pattern. So you take your string and then you do dot, so it's an extension method on it, and then you can just go right down your little regex thing, and then at the end say validate, or yeah. So this should,
like this.
yeah. But at
But
that point, you could probably get away with just using shouldly and just not care about that it asserts rather than returns a bool.
I'm okay with any form of exposure.
Yeah.
What I'm trying to say is that like, okay, do you guys at least know what I'm looking for when I'm saying we need to humanize this?
Yeah, the problem is how you. I don't want to keep reusing the same word, but it's how you describe it in human terms. So how
Yes.
you humanize it is important
Because
because
it doesn't matter how computerized we are. Once you stay away from regular expressions, you're gonna have to go freaking look back at it. It's like YAML. That's why I hate YAML so much. Because it's not intuitive. It doesn't lend itself to you. You know, while you're working, it's blocking you from evolving and progressing. Therefore, it's a failure as a technology.
so
Automatically.
if I was building something like this, I would build it in sort of like I would smash out my idea as kind of like English sentences first. I'd say, okay,
Yes.
I'm gonna describe a thing in
How do you
English.
describe it in English?
Yeah, and then I would
Phone
say, okay,
number in the US
yeah,
starts with 3 digits. I'm spelling out the words specifically, you
Start
yeah,
know.
with
but
+1.
I would then reduce that like to the line that you've put above, which is basically what you did, right? You just internally automatically did that.
Yep.
And then once I'd gotten that, that's when I'd start translating it to the calls, which is what you've written in the line below. But then how that actually translates is the tricky thing, right? Because what you want to end up with is something that kind of looks mostly like what you started off with, if that makes sense. But you skipped a step. You automatically just fluently skipped a step.
That's because we're computerized.
Yeah, because you lost sight of that human element because you're a programmer.
Your brain is doing that, Joe, because you're a programmer, just like he said.
No, the human brain automatically and instinctually will skip steps to get to the outcome as an evolutionary benefit. That's why we see things move out of the corner of our eye.
Yeah, the average person doesn't think like a programmer. They don't think logically. If you think of the brain as being kind of like weirdly a regular expression engine under the bonnet, what it's effectively doing is it's looking for patterns of things that you've seen in your history, and it's matching that to the wealth of experience that you remember, and it's tying all those pieces together and saying, how can I relate to that? And then from what it relates, you then get that understanding. So because the brain's working on effectively past experiences, what we are trying to describe here is an API that relates to the general wealth of experience that most people have. And that's the problem. Building an API that is based on most people's experience is virtually impossible because everybody's different. So you just have to do it based on what most people know about the English language, for example. This is why my favorite APIs are ones like Link, where they think like I do. That you can effectively write out an entire query by just thinking about it as an English sentence. And I think it's the same thing with regular expressions. You could write out an entire regular expression by just thinking of it as an English sentence and writing the equivalent API calls.
I'm trying to think of someone who doesn't write software. Hang on a second. Give me 1 second.
I think we've broken him.
No, you didn't. No, just give me a sec.
Is this gonna turn into a channel on its own? Like a whole. Well, you may as well just make another set of streaming channels or playlists for this.
Well, it is its own project. Hey, Dan.
Yeah.
Yes, I am my own project.
Dan, I have a very important question for you. I'm doing this really hard research, and I need someone who doesn't necessarily is not infected by computers, someone who's not computerized, to answer a simple question for me. Do you want to answer a simple question for me?
I would love to.
Okay, if I asked you to describe how US phone numbers are supposed to look like, what would you say exactly? Like
there's an area code and a 7-digit number.
An area code and a 7-digit number. Okay.
Right.
That's it. That's all.
That's the question.
All right.
Okay, get him to describe the area code. What's the area code look like?
Okay. You already passed the test. You're not infected by computers. Computers are a plague. I'm telling you right now. But let me ask you this. How would you describe the area code number?
It's a 3-digit number.
Okay, a 3-digit number. And then just 7 digits. That's it.
Right, and then 7 numeric numbers. 7 numeric digits.
All right. That's it. Thank you so very much. I love you, right?
I'm just glad to help.
I appreciate you so much. Thank you, Dan. I'll chat with you later. Thank you so much. Take care.
Bye-bye.
Take care. Bye.
What was interesting there was that he completely ignored the use of any hyphens.
Did you see that? So there are two things that happened. First of all, he said, "Oh, it's just an area code and a 7-digit number," right? This is one of my dearest friends, and he doesn't touch technology, and
So if you give a computer that, it's basically saying, "Find me 10 digits."
Yes, but that's your computer programmer brain telling you that that's how the computer is gonna think.
Yeah. So in his head, there was a separation. He just didn't explain that separation to us.
He didn't think he needed to.
Yeah. So this is the difference between a programmer who realizes that they need to be explicit,
Yep.
and the average Joe who doesn't realize or doesn't think in those explicit terms, but their wealth of experience, he's naturally just ignored the fact that there's a hyphen in there because he's just so used to seeing them, and it's a subconscious thing at this point.
And then when we asked him about the area code, he basically said, "Oh, a three-digit code."
Yeah.
Then 7. See, he felt even a little bit, when I told him, "Hey, so how do you describe an area code?" And he said a 3-digit code and then 7 numericals. See, now he's feeling like, oh, I need to be very specific. Anyway, 7-digit number is fine. Digit number. So a 3-digit code and then 7-digit number. Can I go and say, see, the problem is he completely ignored the hyphens, no dashes. And also, so if you were to translate this, you would say expression, right, with see, it's just it's programming languages suck because we're not able, like, it's not natural, like with digits exactly. See, my brain is not working. And then digits.
Random thought. How do people like the Cortana guys, or like people working on things like Siri, how would they solve this kind of problem, right? Because presumably this is an interpretation issue rather than a programming one. This is, how can I relate to the thing that the English speaking person is saying and how can I match that back? So if for example the context is, I know I'm describing a phone number, and if the human says, oh, 3 digits, then 7 digits, surely a linguistics expert would interpret that as, okay, there is some separation between the two, right? So they would infer that there is a separation character somehow.
Yep. So what they would do, I was just trying to find this for you. Azure used to kind of give you a text box in here, and you can just basically go and say, oh, let me just enter data in here, and it'll break it down into tokens. Like every word, and I'll tell you this is a noun, this is a verb, this is that, and then it builds a tree, and then it tries to make sense out of that tree, which is insane,
that,
right?
Does that take into account internationalization and stuff?
Yes.
What was that analytics
engine?
Alpha something or other?
Oh,
Wolfram Alpha.
Wolfram Alpha, yeah.
Yeah.
So that you can say, hey, length of the Golden Gate Bridge divided by the population of the US, and it just figures it out. This is what I'm talking about.
Yeah, but that thing is scary, man. Like, I don't know what this guy even, like, I can go to it and say, what's the average size of men in the UK? I don't know, whatever came to my mind. And I broke it because it'll tell me.
It's going.
Oh, no, it's thinking. There you go.
Ask it how to describe a phone number.
Oh.
Yeah. Ask it, yeah. How to describe a US phone number. Boff.
It's just a robot. You guys, there's no humanity in it.
Right, but it's applying raw logic based on there's some kind of understanding or analytics engine behind that, right? So what I'm saying is, with regular expressions, if you want the human element in there, you're basically going to have to inject some kind of AI. But if you want pure logic, there are ways that you can do it following these kinds of mechanisms, but it's just going to get really expensive.
In terms of what? Like processing?
Yeah, because
who cares? What's the biggest regular expression you've ever seen? 3 paragraphs? Three lines?
We're not processing the regular expression. We're processing building the regular expression.
Oh, I see.
That's a whole different problem.
Yeah. Is there a way we can make the code fluent enough that's predictable?
Yes.
Joe, what Ricardo said yesterday when we were doing a quick demo? He said to me, you can change the options that you can have out of every extension, right? But when I thought about that last night, like, how you go to bed and you think, oh, the session is over, but your brain is still thinking, right? When I thought about that last night, the only difference would be from a particular point to a particular point, and then you're offering all the other options by default for everybody. Anyway, long story short, you know, hey Breno, sorry you missed the beginning of the conversation. We were just talking about, how we want to use regular expressions to kind of find patterns, in the tokenization processing, right? And then we kind of tapped a little bit into, Paul said something to the effect of, well, people don't want to deal with regular expression because it's repulsive. And I was like, okay, we don't have to worry about regular expressions anymore because we are trying to simplify it through a library, right? So that's where we're at. Now you're caught up, and then we just kind of went through that down the rabbit hole of so Paul, let me go back to this. If we were to make regular expressions simple, would it still be repulsive for people to go modify OData rules for tokenization?
If you could reasonably do it, I'd say yeah, potentially, but it would raise some questions about the efficiency of what's produced, right? Because anything that's sufficiently dynamic enough comes with an overhead. And if you're injecting that into your request processing, so imagine somebody's trying to use OData queries at scale, right? So they're trying to do, I don't know, thousands of query translations from strings to something, to,
Mhm.
I don't know, a link expression, right? They're doing thousands of these. What you want is the actual translation logic to be as efficient as possible. If what you're having to do in the middle of that is NLP combined with some AI type thing, in order to make it all magically happen, the overhead for that is going to be like, I don't know, 2
Yeah,
seconds for each
it'll be
query,
its
isn't it?
own size project. Yeah, that wouldn't scale.
Well, the other thing
Yeah.
I was thinking of is why are we choosing that regular expressions might be helpful here? The problem, I believe, the only problem we're trying to solve is how to chunk the string up, right?
How to find the right chunks?
Yeah.
Yeah.
So I mean, regular expressions can do that, but is it the best way for us to do it?
Yeah, I think
It doesn't have
it's
to be
not
the best
necessary
way.
that
Hmm.
a computer is, by definition, much more logical, much more thorough than the average human being. So thinking about this as a human problem is probably an errand that we, don't want to go down.
Okay. How do you want to parse this? Do you want to just, character by character because that means we're going to have to categorize further. So do you guys remember how I said there are operational tokens, there are separator tokens, and there are value tokens? Okay. And we said these categories will help us understand what are we dealing with, right? But then, now I'm thinking these separator tokens themselves, some of them are singular and some of them are range. They're looking for its pair. So an open parens is going to look for its pair as a closing parens. An open single quote is going to look for its pair as single quote, and so on and so forth. If we can define those this way as a
So
convention, and that's back to Breno's. Go ahead. Go ahead.
So when I started with this, I defined them as scope starts and scope ends, and I got that from
I'm
looking
okay
at
with that.
Sam's existing lexicode. He'd already identified that this was a case that needed to be unique, and this
Hmm.
is why I had so many token types in our token, types array or enum, because you keep coming back to this. Hey, there's only 3 token types, and I keep going, well, yeah, but based on how Sam's already solved the problem, he clearly found a scenario where that wasn't the case, and scoping is one of those examples. So to my mind, it seems that tokenization is a little bit more than just string split. We're trying to add a little bit of context into what it is that we're splitting up. So if we're understanding things like the beginning of a scope or the beginning and end of a literal, or, when an expression is a child of another expression, we can encapsulate that in our token information that we generate from this clever split, so to speak. That then means that further down the chain, when we were talking about conventions, right? My thinking was that the way that we could build conventions is we could say, hey, we expect a certain structure of tokens, if you like, in terms of token types as a token group. So this feeds into what Breno was saying in our last section, where we first produce our token stream, and then we analyze that stream by saying, hey, when there are certain groups of them that match a given convention, i.e., there's a certain set of them that are of particular types in a certain order, we can recognize that as being a convention, and we can map that convention into something that can handle that convention. That's kind of where I was going with it.
What's your entry point to figuring out that convention? You're going left to right, right?
Yeah.
You're not scanning, you're not understanding the whole structure and then later on determining where every piece belongs. That's the algorithmic question. That's how we want to tackle this.
I think if we break this into groups and then look at some group as single responsibility, then if one group has one kind of parse problem, then this group will have a result that we can throw or not. So when we break things like this, we can give to the tokenizer service the result of these combinations of group and their results to output these tokens or not. We'll take the problematic ones and throw the problems.
So Breno, help me understand. How do you determine the groups?
So if we look into OData right now in this last version, you see that there is an option on a configuration that says don't use the cipher, just use the
dollar
word.
sign.
Yeah, that means I can change the what kind of the key word I'll use as key to filter, to search, and I can create mine. So if I take this and break 4 keys and values and then parse the values like I want with the parsers I have in my conventions, so I can create mine. I can use some already built parsers, and I can edit these guys. So why I bring this kind of algorithm? Because we can try to separate as key values and then work with the parsing values. Sorry, by my background shed.
No, you're fine. You're fine. I'm just trying to think about what you just said.
Probably the smart way of looking at it, Hassan, is to pull up one of the regular demos that you show off to other parts of the community. And in particular, we should be interested in looking at the initialization code where we're configuring OData.
Yeah.
Because this will give us some hints about what we're actually configuring.
Yeah. So let me. It's not ended. It's not running. But the idea. Let me show you.
Do you want to share your screen? Yeah, go for it.
Yeah. So let's start by the tokenization service that I changed a little bit here. Let me see. Okay. So the Lexus would be the kind of the grouping part that we can set a key. All right. So this key is filter, search, top, skip, and inside the Lexus I have the parsers, so I can get this guys out, the tokens out, based what parser I have, and then I create, for example, conditional that will create an conditional yeah. Then I'm using the filter token, filter Lexer, to take the tokens for filter. It's just the idea, and inside those lexers, I have the parser, and for what I want to parse, I parse with my custom parsers now. So I give an example in the group. If I want to build um, my query as a binary search, so I will not have tried to understand that string in the conventional way or try to map characters. So I just want my lexers, my custom lexer that have a key that I will look into the carry string.
Mm-hmm.
So you have this key. I take this key in value, and then I will have my custom parser here. So in the end, um, I have the options to use the default lexer, so bring with the default configuration for OData, and here I can express the result. So in this group of parse result, we have the lexer key and succeeded errors message and the very one tokens that we are told to get. So this kind of guy will bring me the tokens grouped by key with the successor are not independent of my parsers that I have. So this is the basic idea. The,
I am totally on board with pluggability of Lexer's, conventions. Paul actually talked a little bit about this earlier, but this is very elegant. I'm okay with that, Breno. How are you gonna parse the code? What algorithm are we gonna be using to parse the code? Do we just copy what Sam did in the existing OData and say, okay, just iterate over the string and just find whatever is in there, which is okay? Or do we want to approach this differently? Do we want to go and say, this is my string, it starts like this, it ends like this? Like Breno, the part that you just talked about, that's the exposure part, the pluggability part. I'm okay with that. I'm 100% with you, 100%, right? We were talking about some crazy shit before you joined this session, and we're talking about, lake house and plugging and, being able to actually, literally download a DLL, and that DLL will just plug into the existing one and automatically gets loaded in and processing the work. I'm okay with that, right?
what we are
Me,
talking here, what we try to say that we are trying to focus in the parser. Really,
the
the
actual
parser.
parsing, that
Okay.
stuff that you talked about, that's the packaging and exposure. I'm okay with that, right? The part that I really want us to focus on. So Paul said no regular expressions. Um,
I just don't think they're going to add anything here. They're just going to make our life harder, effectively,
okay, okay,
unless we have something like this library that you're talking about that just gets rid of the problem of regular expressions.
okay, and that's
Um,
okay. Now,
One idea that I've had for breaking down the problem
mhm,
is initially you've got your full string, right? So we've effectively now pretty much come to the end of the tokenization bit of it.
right,
But within that tokenized set, you've got separators that are they're defined as part of the standard for URLs.
mm-hmm,
So they're actual parameter separators, like ampersands, right?
mm-hmm, mm-hmm,
So if I was to split my string out by the ampersands,
mm-hmm,
I could say, okay, everything between some OData parameter token and the
mm-hmm,
next ampersand is an OData parameter that I need to handle. So my
mm-hmm,
thinking was that we could begin by saying, hey, what represents a valid parameter, and make that a pluggable piece.
right,
And then you could say, okay, for each parameter, I'm going to parse the parameter expression, so the set of tokens.
mm-hmm,
And that's where the conventions come in, because the conventions would look for certain patterns, and based on the
yes,
patterns, we
that's
either go down the route of building our own nodes again, or we can take that token stream or portion of the token stream and give that straight into, say, something like an expression builder. I was going to kind of defer to Sam's advice on that one, because he's probably got a bit more experience than we have.
What do you think, Sam? Sam is like, can we start writing code for God's sake? You guys talk way too much.
Please write some code.
I know exactly how Sam thinks. I know his brain very well. You know, he's like, okay, this is great. Where's the code? I want to
Maybe that's
hit
not a
my
bad
corner,
idea.
man. I
Maybe
want to
that's not a
hit
bad
the
idea.
I want to hit the corner with an actual deliverable, man. You know, you guys are talking way too much. So I think to Paul's point, you know, maybe the idea of categorizing these tokens, like let me tell you this, if your token starts, if the first character, and if you just follow me on this one, if your first character starts with a dollar sign or not, you know, however you want to approach this, you know, you can go and say, okay, we expect everything that follows that dollar sign until your next separator token to be a token on its own.
Actually, I was going to do it the other way around. So if you
Go.
look at an existing project and how
Mm.
you set up OData,
Mhm.
you know when you're doing you make the add OData call.
At
and then-
convention, yep.
Yeah, and then you do like dot select, dot filter, dot. Yeah.
Well, not anymore. Sam went ahead and said enable all features. Sam, go ahead. Go
Yeah.
ahead.
So I mean
Yeah.
that's just a wrap around a subset, right?
Yeah.
But I was thinking, what if that kind of thing was like the model that we went round, right? So we would have a sort of set of documentation that says, here's how you build one of those types of extensions. And all it defines in it is it says, here's an OData parameter, and I'm going to match on a specific string. So it'll be $filter or filter. And it's going to say, hey, when it matches this, that's a parameter.
You want engineers to set that up every time they're trying to add OData into their ASP.NET Core.
No,
No.
I'm saying by default, we're going to do all that as a one-liner.
Okay, yeah.
But if they
Okay.
extend it, if they want to have, dot or dollar do foo stuff, then they can do that. But they're building an extension, right?
I'm okay with that. Can we at least agree we need some sort of a model that represent the rules of parsing?
Yeah.
And this model that represents the rule of parsing, if I go here and say for every dollar sign, go ahead and parse until your next separator token. And that's a rule.
Haven't we solved that?
The next key, right? Not the separator, so to the next key. So the next group of, because I can have a dollar filter, or I can have the home key, that represents some kind of another filter. So maybe with dollar or not, or with another key.
So Breno, you're saying you want to kind of say this here, from here to here, this is a group.
Perfect.
And then where is your next group? Is it the name, or does it start from the equal sign?
No, the next group will be the name, a key, the name, a key, and value will be the value of the filter group. So in the next group, I'll have the another values to parse.
Yeah, but now you're building OData tree. We're just trying to tokenize, brother. That's an OData tree, what you just said. You're giving me a key and you're putting values, and inside these values there will be other keys that have other values inside of it. That's the tree.
Are we potentially moving into rebuilding the O-node stuff?
I'm trying to prevent us from doing that.
Yeah.
But just hear me out. Maybe this will work. I promise you. This feels so good. Okay, that part that I'm just telling you about. If you start with conventions that say until you meet the next separator token, then that's how you're gonna break. So this is me stealing Breno's idea of adding these conventions, the elixirs, except that the description is different. The description is a little bit different.
So let me.
Not yet, Sam. Not yet. I know what you're looking at. Not yet. Just 4 more minutes. Go ahead, Breno. Go ahead.
Tell me if I'm wrong. So you're telling me that the default Lexer way to bring these guys is always have the separator like this. In this case is unequal.
No, it would be a separator token, whatever that separator token is.
Whatever the
like you could have something like this, and Sam, correct me if I'm wrong. If we added a space in here, OData still should work, right?
Yes.
Yeah. So that space is still a separator token. It doesn't have to be equal. That's what I'm saying. So you're saying, the rule is anything that starts with a dollar sign and ends up with a separator token makes this entire statement in here a token.
Do you think we
I'll come up with a POC next time.
Same as the name, both
Mhm.
are the identifier. So dollar field and the name has the same power, has the same, sorry for my mouth, has the same right
Mhm.
within the clause.
Yeah, it would be the equivalent of this, Sam. Even if you said, I don't want to use the dollar sign,
Mm,
and there is like a question mark, and this question mark would be its own thing. It doesn't matter. That makes this filter its own token, and that's
mm,
still okay.
mm.
I think I have an idea. Let me show you this idea next time. Let me show you that idea next time. And if you like it, we'll move. If we
okay?
don't, we will keep arguing each other to death
Just,
until we
just try.
figure it out. Go ahead.
Let
Go ahead.
me add you something to your thinking process
Mhm,
the next
mhm,
next time.
mhm,
Thinking like we are, yeah, yes, we are parsing URLs here, but thinking maybe to that we have a JSON structure, that we have the key and the value should be the value in the URL. So if I don't have if I don't want to use OData in a URL and I want to parse OData from key value JSON, for example, if I have different separators, then what kind of key I will look into this JSON, because it's the that what we are targeting here. So extensibility, compatibility, protocol, different, blah 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 blah. Right?
That's the O node problem, isn't it? It's where you've got a query but in a different data format. What we're
This
talking about here is taking purely an OData query
and you
in
yeah,
as
go
a
ahead, Paul.
string and processing that. So one of the things that we were playing with earlier on in the project was taking this and translating it into a tree of nodes, essentially.
Hmm.
And if you serialize that into JSON, you'd end up with exactly what Breno was talking about there, essentially.
Breno,
Um,
please watch video 7 and 8. That's exactly where we start talking about O node. There's a
Okay.
bunch of things. There's a bunch of things at the beginning of this series where I talked to Sam and Michael, and then we talked to Christoph, and then we talked to the Oasis team, and then Sam did a walkthrough through how OData works today. This series is long. It has so much history in it, which I love it, because you're gonna see how we're meeting with all these different kind of people. And now this is how I know we're going crazy. We're calling people randomly on the phone, telling them, "Hey, how do you describe a phone number in the United States?" This poor Dan, he's probably thinking, "What is this freak is up to right now?" But anyway, I think I can come up with something to show for next time on Freud Day, right, Paul? And and I appreciate the feedback. I think we might be up to something. And the only way, see, the beautiful thing about this is that computers have no friends. If we're wrong, we're gonna discover that we're wrong really, really fast. The other thing
compiler
that
doesn't care. You've either got it right or the compiler will shit all over you.
compilers, you can't give compilers a gift and say, just let me go this time. They'll be like, no go Tokyo. Sorry, it's not gonna happen. The other thing is, I want you to understand this very discussion itself is a product. Try to extract as much as you can, from these discussions. It's not about the end goal. The end goal is going to happen and then we'll wrap it up and publish it and we're done. But you will discover that this very conversation is what really, really has the highest value in developing this feature. Anyway, thank you all for hopping in today. I appreciate you. Sorry, Sam, there's no coding today, but we'll code next time. And for the people watching us as usual, feel free to drop a comment in the comment section, and don't forget to like and subscribe. See you guys later. Thank you. Take care.